All right, so good morning. It is Thursday, but it's kind of your guys' Friday because we don't have class tomorrow because we only meet Mondays through Thursdays. So this says get out notebooks, pencils, calculators, graphing paper if you have it. Make sure you have all your materials out. Find the slope and plot the line. So we can approach this a few different ways. So we actually know how to find the slope with 2 points. So we could do it that way. Also, morning, Diego. Let me just write down that you got here, Diego. Okay. So we can use that y2 minus y1 divided by x2 minus x1 to figure that out. We could also plot these points and look at the line. So a few different things that we can do. I'm going to go ahead and plot them on the line. So I'm going to do both because, you know, I'm a little extra. So I'm going to make this the origin. I don't know if you guys can tell, but that is the origin. It's kind of hard to see. So that's 0, 0. So I'm going to plot 2, 2. So I'm going to go over 2 and up 2. And then 1, 0. So over 1. All right. So for this one, I tried to draw a straight line. So we've got a line. I want to figure out the exact slope. So we can do it 2 different ways. I'm going to check it both ways because it should work both ways. So I'm going to work on I'm going to do the easy one first, and then I'm going to do the more challenging way or more complicated way second. So I'm going to look at my rise over my run. So if I'm looking at this graph, it's going up. So that means from left to right, it's going in an upward trend, which means it's a positive slope. So I'm going to go ahead and look at my rise over my run. So we're going from this point, we're going up 1, 2, then we're running 1. So our rise is up 2 and our run is 1. So 2 divided by 1 just gives us 2. So our slope is 2. However, I'm going to also use our y2 minus y1 formula. So I'll write that down for those of you who don't have it in your notes. Make sure that you do have it. So y2 minus y1 divided by x2 minus x1. So this is important. This is our slope formula. So this is how we find slope. And again, guys, the letter M represents slope. So I'm going to take my x value. So or my y value, excuse me. I'm going to highlight my y values and I'm going to highlight my x values. And then I'm going to make this 0.2 and this 0.1. Remember, y2 doesn't mean that y is 2. It means that you're taking the second point minus the first point. So you're taking the difference in 2 points. So I'm going to take y2, which is positive 2. It's that yellow one. So 2. So y2 minus y1, so 2 minus 0, divided by, and then in our green, we've got 2 minus 1. So 2 minus 1. So 2 minus 0 equals 2. 2 minus 1 gives us 1. So we still get the same slope. I like making these connections for you guys that everything we've learned so far is all connected. We can use a bunch of different ways to solve something. So we found the slope. It's positive 2. It's going up 2 over 1. So it says write the equation if you can. Well, we can write the equation. So if remember, we've got y equals mx plus b. M is our slope and b is our y-intercept. So in this case, I'm going to have y equals, our slope is 2, x, and then plus b is our y-intercept. So where does it intersect y? If we're at this rise over run, we're going to intersect right here at -2. So y equals 2x minus 2. All right. Any questions about that? All right. So far this week, guys, we talked about slope using rise over run. So finding those 2 points and figuring how much the change in y is, and then divided by the change in x. So rise divided by run. Then we figured out slope from point. So how to figure out that y2 minus y1 divided by x2 minus x1. So slope from just points. And yesterday we talked about writing equations. Today we're going to talk about interpreting everything we've learned and kind of applying it to different scenarios. So we're learning so many different skills in this unit. I just think it's really important to just keep reviewing, keep practicing in different scenarios. So we're going to look at a couple of different problems today and work on interpreting and using everything that we've learned in the past couple weeks to solve them. So this first one, fun fact about myself, I actually used to work at a pizza restaurant. I used to work at 2 when I was in high school. I worked at Marco's Pizza, love Marco's. And then I also used to work at Pieology, which is like one of those places where you assemble, like you go down the line, kind of like Chipotle of pizza. But so I make a really good pizza. All right, so this says a restaurant offers delivery for their pizzas. The total cost is a delivery fee added to the price of pizzas. One customer pays $25 to have 2 pizzas delivered. Another customer pays $58 for 5 pizzas. How many pizzas are delivered to a customer who pays $80? So lots of stuff going on, but this is nothing that we can't solve. This is we've learned how to solve something like this. So one customer pays $25 to have 2 pizzas delivered. Another customer pays $58 for 5. And then we want to know how many pizzas are delivered to a customer who pays $80. So what I want you guys to do is on your own, either your notebooks or a piece of paper, I want you guys to write a table. So go ahead and write a table. We're going to have x over y, and our x is going to be pizzas, and then y is going to be dollars. All right, so go ahead, I'll give you a second to write that down. So I want you guys to write a table. If you guys remember in our proportional relationships week, we talked about stuff like this. Let's see, Quiche has just arrived. Let's see. All right, so in this table, I want you guys to write that first one. So one customer pays, I want you to leave the first one blank. So we're gonna go, so one customer pays $25 for 2 pizzas. Another customer pays $58 for 5 pizzas. How many pizzas are delivered to a customer who pays $80? So up here is our question mark. Now, the reason I left the first one blank is we're going to find our unit rate or our constant of proportionality. Remember, we talked about K as a unit rate a few different times, but this is where it comes in handy. So to figure out the constant of proportionality, we take y divided by x. So I'm going to take my calculator. So in your calculator, I want you guys to type in 25 divided by 2, because that's y divided by x. So what do you guys get? Good, guys. So our constant of proportionality, I want to make sure that it's the same, but for this first one right here, 25 divided by 2 gives us 12.5 over 1. I'm just going to double check. I'm going to do this second one right here. So we're going to take 58 divided by 5. So 58 divided by 5. All right, so we get 11.6. I think I meant to, when I typed this, I think I meant to put 6250. I'm sorry, guys. All right, so I think I mistyped this because I meant for this to be a proportional relationship. So right here where it says 58, that's my bad. I meant for this to be a proportional relationship. So we're going to write 6250. So it's going to be 6250 for 5 pizzas. So what is 6250 divided by 5? I'm sorry, guys. I meant for it to be a proportional relationship. So 6250, so 62.50 divided by 5. Good, 12.5. So that's, I think I mistyped it. That's my bad. So what I want you guys to notice is the constant of proportionality is going to be the same for both of these. So what we can write in this first box is we can write the price for one pizza. So I'm going to write, so for one pizza, it's going to cost $12.50. Okay. So if one pizza costs $12.50, how can I figure out what 80 pizzas is going to cost, or $80 worth of pizza is? Remember, we can use our constant of proportionality as, and we can write it as an equation, guys. So we can take this k equals yx, and we can write it as y equals kx, if you remember. So if we're doing y equals kx, we can write y equals, not 1.25, 12.5 x. So y equals 12.5 x. So that would be our equation for this one. Remember, all we're doing is subbing in that constant of proportionality for that k. So we want to figure out what x is. So we're going to plug in our y value for y. So we know that 80 is the y value. So I'm going to go ahead and plug in 80 for y. So 80 equals 12.5x. So this goes back to our equation solving unit, guys. Do you remember how to get x by itself? So we want to isolate x, we want to get x by itself. How can we do that? And by that I mean, are we multiplying, dividing, subtracting, adding? What do you guys think? It's okay to be wrong, because I'll explain it either way. So I'm seeing a few different things. So to get x by itself, what do we need to do? So I see multiplying, adding. So right now, guys, 12.5x is the same thing as 12.5. Let's extend the page so I have a little bit. Is the same as 12.5 times x. So this is the same exact formula. So if we want to get x by itself, we need to undo that multiplication between the 12.5 and the x. So how do we get 12.5 away from x if we're going to do the opposite of multiplying? What is the opposite of multiplication? Yay, divide, good. So we're going to go ahead and divide both sides by 12.5. So I'm going to divide both sides by 12.5, and that's this. So whenever you see a number directly next to a variable, like in this case, it's we can automatically assume that it's multiplication. So to undo multiplication, we're going to divide, okay? So good. So that's going to cancel on the right side. I'm going to have x equals, and then what is 80 divided by 12.5? All right, good. So 6.4. So it doesn't make sense that we're going to have 6.4 pizzas. So I kind of want you guys to start. This is a weird problem. I must have either mistyped it or used the wrong numbers, but I like the concept, but we're getting some weird answers. But typically you wouldn't get 6.4 pizzas. You would either get 6 pizzas or 7 pizzas. So we're going to say for $80, you can get 6 pizzas. But that makes sense because to get from our y to our x, we're going to divide by 12.5. And then to get from x to y, we're going to multiply by 12.5. So remember that first week we talked about proportional relationships. I want you guys to remember there's a relationship between those numbers. So just keep that in mind as we're going through this. That was kind of weird problem. I thought I liked it, and now I'm like, I don't know if I like that problem as much. All right, any questions about this one? All right, so I don't know if any of you guys enjoy running or enjoy cross country or any sports or anything, but this one is about the cross country team. So Tyler and Elena are on the cross country team. Tyler's distances and times for training are shown on the graph. I'm gonna move my chat. I don't know if you guys can see my chat bar, but it's like right in front of the problem. All right, so Tyler's distances and times for a training run are shown on the graph. All right, well, right away, I want you guys to write in the chat, is this a proportional graph or a non-proportional graph? We talked about the difference yesterday. Well, actually, we talked about the difference 2 weeks ago, but we revisited this yesterday. So is it proportional or non-proportional? So if you guys remember, a proportional graph is a straight line. Is this a straight line? Yes. And it goes through the origin, 0, 0. It goes through the origin right here. It's a straight line. So yes, it is proportional, which means, because remember, the lines that we talked about yesterday were the ones that were like this, that went, that were straight lines, but they went through somewhere else on the y-axis. So this is a proportional relationship. So just keep that in mind as we're going through this. So being able to identify the difference between proportional and non-proportional is important. The only difference is proportional is on the origin, non-proportional is not on the origin. All right, so we have Tyler's distances and times for training. It's shown on the graph. Elena's distances and times for training for a training run are given by the equation y equals 8.5x, where x represents the distance in miles and y represents the time in minutes. So we had practiced doing this a few weeks ago. I think it was on our first week of proportional relationships. So we've got Elena, this is her equation, so y equals 8.5x. Remember, y equals kx is the formula for a proportional relationship. So that k is her constant of proportionality, or her rate in which she runs. So to come up with a similar equation, we're going to write one for Tyler. So we need to find a point on the graph that intersects with yx. So I don't know if I can make this any bigger, but whoops, I don't think I can right now. So go ahead and look for a point on the graph and put it in the chat that we can use for Tyler. And what I mean by that is find a point where that line intersects with both the x and the y axis. And again, it's okay if you're wrong. So what I'm asking you guys to type in is something in the format of like x, xy. All right, so if we're not sure, that's okay. So what we're gonna do is we're gonna find a point where this line meets the x and y axis. So what I mean by that is this isn't a good spot for a point because it doesn't meet the y axis. It meets on the x axis, but not the y axis. This isn't a good point because it doesn't meet on, good, Ari. So you guys are really close. I know it's kind of hard to see on the screen and like count with your finger and everything, but good. So I'm seeing people identifying this point right here, which is perfect because we want to figure out one that intersects the, where the line intersects the y and x axis. So we're going to go over 1. So our x is 1 because it's on the y-axis at 1. And then we're going to go up, let's see. So 8 would be this line right here. So I'm going to kind of erase just so I can make sure we're being precise. So 8's going to be right here. So it looks like it's a little bit more than 8. So let's see how I'm going to count how many lines we have in between. So we've got 1, 2, 3, 4, 5, 6. So about right here would be 9. So we're going to say it's 8 1/3. And I know that's tricky, but those of you who said 1,8, really good job. That means that you guys are understanding, which makes me feel good. And I've been looking forward to this class all day because my in-person kids are taking a test. So I was like, I'm excited to teach. So I'm happy that you guys are sort of understanding. All right, so we've got 1,8, and we'll do 8 1/3. Okay, so remember, to find what k is, we're going to take k equals y over x. So if we just take 8 1/3 divided by 1, we're going to get 8 1/3. So so for Tyler's distance, his constant of proportionality is 8.3. We'll just say that because 8 1/3 is the same thing as 8.3. All right. So we want to plug Tyler's, I know I always draw all over the place. I'm sorry, guys. We want to plug Tyler's constant of proportionality into our proportional relationship formula. So y equals kx. We're going to plug this in for k. So what is that going to look like if we're plugging in Tyler's k value into this formula? All you have to do is plug in. I just want to make sure that you guys can kind of do it on your own before I give you the answer. Yay. Good job, Ari. Good. So we're going to take this k value and we're plugging it in for k in that formula. So Tyler's, and I'll write it next to Elena's. So Tyler's equation is going to be y equals 8.3x. So we've got two different formulas, Tyler and Elena. Who ran farther in 10 minutes? So remember, let's see. Time in minutes, that's going to be my y value. So what I can do is I'm going to rewrite. So I'm going to write y equals 8.5x. And then I'm going to write y equals 8.3x. So those are my two formulas. If I want to replace, so I want to figure out who ran further in 10 minutes. Well, 10 minutes is going to be my y-axis. So I'm going to replace my y value in both of these with 10. So all we need to do to figure it out is we're going to get x by itself. And remember, we get x by itself in the situation by dividing. So I'm going to, I know I hate that I have no space to write this stuff. So I'm going to write it down here for right now. So 10 equals 8.5x. Remember, to get x by itself, we're going to divide both sides of the equal sign by 8.5. Because remember, 8.5 is being multiplied by x, so to get x by itself, we're going to divide. So x equals, and then what is 10 divided by 8.5? It's a weird decimal. Just go ahead and round it if you can. Good. So you should be getting something like 1.17647, something like that. But we can round that to 1.18. So x is going to equal 1.18. And this is for Elena's. So then for Tyler's, I'll do it in a different color. So for Tyler's formula, we're going to have 10 equals 8.3x. And we want to get x by itself again. So we're going to go ahead and divide both sides by 8.3. Are there any questions of why I'm dividing by 8.3? I'm doing that because I want to get x by itself. Right now, x is being multiplied by 8.3. So to undo that multiplication, I'm going to divide. So that's going to cancel on either side. I'm going to have x equal, and then what's 10 divided by 8.3? Good, Maya. So 1.2. Oh, that looks like 12. So 1.20. So in your calculator, you should have put 10 divided by 8.3, and you should have gotten 1.204819, but we rounded to 1.20. So this says, who ran farther in 10 minutes? So X is distance in miles, remember? So during our applications unit, when we talked about, or our equation applications, we talked about our X has a meaning. So our X has a purpose. So X is representing distance in miles. So which one ran further? Which one's bigger, 1.18 or 1.20? Good, guys. So 1.20. Good. All right. We could do all of these problems. You would be able to do all these. So when it says calculate each runner's pace in minutes per mile, that's a unit rate. That means calculating pace per mile, which we already did. But I'm going to move on to the next problem since I just heard the alarm or the bell beep. I was like, it's already 10 o'clock. It makes me crazy. All right, so a U-Pick blueberry farm offers 6 pounds of blueberries for $16.50. So if you guys have ever been to like an apple orchard or a pumpkin patch, one of those places where it lets you like pick your berries or fruits or something like that, that's kind of what this situation is saying. So this says sketch a graph of the relationship between cost and pounds of blueberries. So this is just graphing practice, but what we can do, so we know that 6 pounds of blueberries. So if I go to the graph and I go to about 6, so 6 pounds of blueberries cost $16.50. So $16.50 would be about here. So my first point would be about there. So I can, and if we remember, we can do, oops, not like that. So X, Y, we can always write a table, and remember, tables, graphs, and equations are all related. We can use them to solve basically anything. So for this one, our X value is berries, so berries, and then Y value is dollars. So if it costs $16.50 for 6 pounds of berries, let's see, let's make it, so we can write an equation for this, right? So using what we know, K equals Y divided by X. What's the constant of proportionality? And I know this isn't necessarily what we've done this week, but I did want to review this with you guys because it is important to have this understanding. So what is the constant of proportionality for this one? Good, Ari. So 2.75, so Y, so if we take 1650 divided by 6, we're gonna get K equals 2.75. Well, that means that for 1 pound of berries, it costs $2.75. So we can use, so we can write an equation for this, remember? We can take Y equals KX and write an equation. So I can plug in whatever I got for K into our proportional relationship equation. So if I use that and wrote an equation, it would be Y equals 2.75X. So I'm going to go ahead. I'm going to find another X value. So I'm going to take 30 because I want to point up at 30. So let's plug in, this will be our last problem for today. So I'm going to plug in 30 for X. Remember, all we have to do, you're multiplying 2.75 by the x value. So all you're going to do is take 2.75 times 30. So 2.75 times 30. What do you guys get? Good, Maya. So you should get 82.5. So what this means at 30 pounds of berries, I'm going to have 82.5. It's going to cost $82.5, which I don't know why you would need 30 pounds of berries, but maybe you do. All right, so 82.5. So I'm going to go to 30 pounds of blueberries, and then I'm going to go up, let's see, all the way to 82.5. So 82.5 would be about here. So then I could draw a line that went through. It's a straight line. It goes through the origin. It's a proportional relationship. So that's all that it was asking you to do. So I think this is important because we kind of blew over proportional relationships, and it is an important skill to understand how it applies to different things. Let's see. I was going to go over this one, which is kind of more relevant, but we are out of time for today, which makes me sad because, oh, that was me balling, I guess. Let's see. All right, so I'm going to stop sharing for today. Does anybody have any questions about anything?